start new theorem, that is theorem of Pythagoras. See the statement, in a right angled triangle, square of hypotenuse is equal to the sum of square of remaining two sides of a triangle. So we have to prove this. Now see, for that we have to draw right angled triangle ABC. This is our triangle ABC, in which B is 90 degree, right angled triangle. See the statement once again. In a right angled triangle, square of hypotenuse. Now everybody know hypotenuse is the side opposite to 90 degree. So square of hypotenuse means what we have to prove? To prove is square of the hypotenuse, means AC square is equal to square of the hypotenuse is equal to the sum of squares of remaining two sides of a triangle. Remaining two sides are AB and BC. These are the two remaining sides of the triangle, and sum of square of these two sides we have to take. Means in short, AB square plus BC square, like this we have to prove. So AC square is equal to AB square plus BC square. Hypotenuse square is equal to sum of squares of remaining two sides of a triangle. So what is given in this theorem? In this triangle, what things we see? It is the given. We see only the right angle triangle. So we will write in triangle ABC, angle ABC is 90 degree. This is the thing, only given thing. So construction we have to do. See what construction is there. We have to draw a perpendicular from the vertex B on the hypotenuse. So BD is perpendicular on AC. This is our construction. Sec BD we draw perpendicular on the sec BC, means on the hypotenuse. This perpendicular is drawn from the vertex from the right angle on the hypotenuse. Now proof. See in the proof. Actually, three triangles we are getting in the figure. First triangle, second triangle, and the original triangle, larger triangle. But see, in our previous session, we saw that first triangle is similar to larger triangle. Second triangle is similar to larger triangle. Directly we have to write now because we know. And for that I shared this first triangle. So how to read this triangle? See, triangle ADB is our first triangle, smaller triangle. Triangle ADB is similar to triangle, original triangle ABC. Proper sequence should be maintained. ABC. See how I maintain the sequence. See, A is congruent to A, means A in the smaller triangle, similarly A in the bigger triangle. D is 90, B is 90. D is here 90 degree, and in the larger triangle B is 90. So that proper sequence should be there, and directly we have to give the support. Similarity in a right angled triangle. Similarity in a right angled triangle. Now you know, see, when the triangles are similar to each other, we should remember two things. First is, its sides are in the proportion and angles are correspondingly congruent to each other. So we are related with here with the sides of the triangle. So what sides are there? See, AD upon AB, DC DB upon BC, that is equal to AB upon AC, and the support is corresponding sides of similar triangle. Now out of these three ratios, we have to choose two such ratios where you will have a repetition. So I think here in the first and the last ratio, if I consider these two first and the last ratio, I get here AB and AB, and the cross multiplication now we have to do. So in the crossing you will have AB square is equal to AD into AC. AD into AC, and this is our first equation. Now same thing we have to carry in the second triangle and in the original triangle. So what is the name of second triangle? BDC. See the proper sequence. BDC is similar to triangle ABC. And once again we have to verify whether we are correct or wrong. See children, D is 90, B is 90. D is here 90 degree and angle B is 90 in the original, and C to C, that is the common. How we studied in the similarity in a right angled triangle. So it is correct equation, and the support is same. Similarity in right angled triangle. Now again, these two triangles are similar to each other, means its sides are, corresponding sides are in the proportion. So we have to take sides in the proportion. BD by AB is equal to DC upon BC, and that is equal to BC upon AC. And the support is corresponding sides of similar triangle. And again, out of these three ratios, we have to consider, we have to choose these two ratios, because here is the repetition. After taking cross multiplication, you will have BC square. So these two I am going to consider. BC into BC is BC square, that is equal to DC into AC, and this is our second equation. See children, two equation we got. What is our first equation? AB square is equal to something. We are not going to study the RHS of that equation here also, and BC square is equal to something. Now come to prove what we have to show. AC square is equal to AB square plus BC square, means in the right hand side of this equation they added these two squares. AB square and BC square addition had been taken here. So same addition we have to take, means we have to add equation first and the second. Add right hand side to the right hand side, means you will have AB square plus BC square, that is equal to, now we have to add it, AD into AC, whatever RHS are there, we have to add them, DC into AC, and the support is from equation number 1 and 2. Now see, very important thing is there in the right hand side of this equation. You will see AC is common. Now remove this AC as a common from this two term, and you will have AB square plus BC square, that is equal to, what is common here? AC is common. So you will write here AC into curly bracket. Now AC is common. So what is left behind? AD plus, here is AC common, means DC. AD plus DC. And curly bracket complete. Now see, for this bracket we have to see the diagram. AD plus DC means what? See, here is our AD and here is our DC. So AD plus DC means entire length of the hypotenuse, and that is AC. So instead of that we will put its value as, this is our previously AC into the value of AD plus DC is again AC, means AC into AC is AC square. So, means in short you had proved that, we had proved that AB square plus PC square is equal to AC square, means LHS is equal to RHS, meaning is one and the same. There we had considered AC square is equal to AB square plus BC square. I think we got the answer over here. AC square means hypotenuse square is equal to, this is AC is the hypotenuse square is equal to sum of squares of remaining two sides of a triangle.